Hi, my name is Robert Kane, and welcome to Advanced PowerShell Programming. In the previous lesson, we covered the basics of PowerShell programming. In this video, we'll dive even deeper, getting into the more advanced features of PowerShell development. We'll start by creating our own functions, which can act as our own version of custom commandlets. We'll see how to add help to our functions, as well as how to handle errors. Next, we'll look at how to work with the various file types in PowerShell. Finally, we'll wrap things up with how to handle user interactions in PowerShell. Beyond script blocks, we have functions. A function is essentially a script block with a name. There is one other important difference in that to pass parameters into a function, we actually place those parameters in parentheses after the function name instead of using the param keyword. Here I've got an extremely simple function called getFullName. Note that I've used the verb-noun syntax traditional of a commandlet. For the two parameters, I have first name and last name, and the function simply prints them to the screen, putting a space in between them. I can create the function by simply executing it, and now I can call it by simply putting the name of the function with my parameters. And there we go, I've put it on the screen. Now, unlike other languages, you'll note that I don't have to use parentheses when I call it, or even commas. I simply use a space between each one of my parameters. If I have a situation where I want to actually affect the value of a parameter that's getting passed in, I actually have to use the reference designator. Here, I'm going to use the bracket ref in front of the name of the parameter, which is going to be an indicator that I actually want the function to pass the calling variable and not work with a local copy. Note, too, that by using the ref command, it actually turns it into an object, hence we have to use the .value syntax. I'm going to get the function created. I'm then going to assign the value of 42 to my function variable. I'm going to print it out. I'm then going to call the function, and I also have to add ref to the function call here. Note too, I'm also having to enclose it in parentheses so that PowerShell won't confuse the bracket ref with a second parameter. Then finally, I'll print out its new changed variable afterward. And you can see here, it did indeed work to affect the parent variable that was passed in and not a local copy. It's also possible, and even desirable, to have functions work with the pipeline. You can see here the syntax is pretty much identical to what we use with script blocks. We have the begin, in which case we're going to display something before the process begins. Within the process, we're going to loop through each item that's brought in for the pipeline, and at the end we'll do something. So let's create the function, and it's now created. And now let's call it, and I'm going to take what is in getChildItem and pass it to my getCoolFiles function that I just created. And here we go, it displays it on the screen. Now, while the above works quite nicely, it does tie our function to only work with .ps1 files. We can actually create an alternative to functions called filters. A filter works something like the whereObject commandlet. The filter takes what is passed through the pipeline and looks for something specific within the object set that's coming in and only returns certain objects based upon whatever code you have in the filter. So here I've got a filter called showps1 files. I then set a local variable of file name to the current object's .name property. I then compare my file name to see if it's a PS1 file, and if so, I return that object. So let's run the filter, and I've now created it, and we'll come down here so we can actually use it, and we'll clear the host, and you're going to see that we're going to use getChildItem with our showps1 files. Now note, this isn't calling our function, so we're actually simply taking what was in getChildItem, passing it through our custom filter to remove anything that wasn't a PS1 file. Here, I've got another function called list file names. Now, list file names takes whatever's coming in through the stream and simply displays it on the screen. Note though, unlike the getChildName function, this one doesn't do any checking for any kind of PS1 name. It simply takes whatever the objects coming in are and displays the .name property to the screen. So let's create our function. And now, when I pass getChildItem into list file names, it returns just the names for all my files. Now, I can combine both my filter and my function into the pipeline to give me some really good flexibility. Here, getChildItem returns all of the files in my current folder as objects. It then pipes that through showPS1 files to remove those files that are not *.ps1. It then passes that list of objects into list file names, which then iterates over that list of objects and displays the .name property for each object. Now where this starts becoming really useful is when I start creating other filters to work with it. Here I want to create a filter for just my .txt files. So let's highlight this and run it. And now I have a second filter called showTXT files. When I put it instead of the showPS1 files, you can see it only shows me my text files. Now I have two different ways that I can use my same function. We'll clear the screen and we'll do both showPS1 files and showText files. And there we go. Down at the bottom you can see it first listed my PS1 files, then my text files. So whenever you can, think about breaking things down into the smallest possible unit of work, and then you can use filters and other functions to combine their power together to create really useful, flexible commandlets that you can use within your programming. Now, just like my function can consume pipeline objects, it can also output to pipeline. To do so, it's a simple matter of using the write-output. So here I'm going to create a simple function called getChildName. And what I want it to do is have the equivalence of doing getChildItem with selectObjectName. So let's clear the host, and this is the actual output that I want to see when I'm done. It's just a listing of all the file names. So let's create a function. And now if I just want to call getChildName, you can see I have the same output as earlier. But now I can take what is in getChildName and take its output, pipe it through where_object, and now I only get my PS1 files. So sending things out the pipeline is just a simple matter of using the write-output. One last thing to show you on functions. When we were discussing commandlets early on in this series, you saw that many of them supported various switches, some of the most useful being the -verbose and the -debug. Well, it's possible to support these within your own functions. To do so, you need to know that PowerShell has a handful of special built-in preference variables. The main two we're concerned about is $debug preference and $verbose preference. Now, when these are set to their defaults of silently continue, anything that uses the command to display things to the debug or to the verbose streams are essentially ignored. If we want them displayed, we have to change their values to continue. So here, within my function, I have two special parameters set up. I've designated these to be switches, which means I'm not actually looking for a variable to be passed in. With a switch, I'm looking for a dash and then the word verbose, or a dash and then the word debug. Within the context of my function, these are actually labeled as $verbose and $debug, but they're not going to have any data in them. Also, note that here I'm using the words verbose and debug, but I could create my own custom switches if I wanted to. All I would have to do is use my own name in lieu of verbose or debug. So here with the param, what I need to do first is check to see if that switch was used. If $verbose .isPresent is true, then I'm going to change my verbose preference switch to continue. Otherwise, I'm going to make sure it's set to silently continue. The same thing for debug. I then use the write-verbose to display extra verbose information to the display. I then have my right debug to display other information to the debug stream. So let's run this. There we go. And now I have my function called 3 times. The first time I call it, I'm going to call it without any switches. And you can see it's displayed things on the bottom, but it hasn't displayed any of my extra text. If I scroll back up, you can see there's nothing extra there. Now if I use the dash verbose switch and I scroll up, you're going to see in big blue text it put current working location is, and it has my current working location. If I call it using the debug switch, you can see it display the debug at the bottom, but it's lacking the verbose at the top. Finally, I can put in both switches to get both my debug and my verbose text. One of the wonderful things about PowerShell is the rich help that is provided with each commandlet. It's possible to add help to your own functions that you write, and fairly easily. By default, PowerShell doesn't give a lot of help when you create a function. Here I'm going to call getHelp on the getChildName function that I created previously in the series. When I run this, all it really shows me is that I support 2 switches, dash verbose and dash debug. Creating help, though, is as easy as putting comments into my function. All I have to do is to create a comment block. Within that comment block, I then use special tags that PowerShell has established and that its getHelp function will understand. These tags all begin with a period. So here you can see I've got period synopsis, period description, period parameter name. These are all pretty self-explanatory. Note that I don't have to use each one of these within my help system. I could choose to just be simple and only use .synopsis, so I just get a brief description of the command. Note that .link may be a link to a URL for more help. If I want to learn more, you can go to Get Help About Comment-Based Help for a full list and all the details that are associated with writing help. But let's look at a simple example. Here I've got my function name, and then the first thing I do after I create the block is I put a left arrow and then the pound sign. This is the opening tag for my comment block. I then have my .synopsis followed by the synopsis itself. I then have the description in the description, and so forth. I have my examples, my link, and then I close up my block, and then finally I actually have the syntax itself that's going to be executed when I call this function. Now you can see here that for my simple functions, oftentimes the help will wind up taking up more space than the command the function itself executes. So let's run this. We recreate our function. Now our function has the help in it. We'll clear the screen, and then we're actually going to call getHelp on our function. And now you can see we actually have some nicely detailed help on our function. There's the name of the function, its synopsis, the syntax, and more. If I want to see more information, I can come down here, and I can use the getHelp full switch. And now, in addition to the other text, I also have all of my examples. Writing help can be pretty simple, straightforward, and quite useful. I highly encourage you to put help into all of your functions, especially if it's going to be ones that you're going to want to share with your friends and coworkers. Let's face it, no matter how wonderful your PowerShell program is, at some point something's going to go wrong. To help you handle those situations, PowerShell has some really extensive error handling capabilities built into it. As a matter of fact, they're so extensive, there's no way we could cover them all in this little short segment. But we are going to show you the very basic of error handling capabilities and it's enough to get you up and running and have the ability to recover from errors within your applications. Let's take a look at this little simple function called diver, and all it does is it divides an numerator by the denominator, and it displays us some debugging information to let us know that when it begins, when it ends, and what the result is. So let's highlight this and run it. And we've got it as a function now. And let's run it. And we're going to take 33 and divide it by 11. And it's going to give us the result of 3. So now let's come down here and actually do something that's going to cause an error. We're going to take 33 and divide by 0. And now we get this really ugly error message, attempted to divide by 0. And it gives us all this error text. And then it comes out and still tries to keep running by showing us our result, the fact that it's done. Well, we'd like to be able to handle this internally within our particular function. So for that situation, we have a function called trap. If I come down here, you're going to see the trap code followed by a script block. So here, if an error of any type occurs within my function, it jumps down here to the trap and executes what's in the script block, in which case I simply write, oh no, an error has occurred. I then access the generic variable of $underbar, and I retrieve the error ID and display it and the exception message. I then use the continue keyword. Now you may recognize this from our looping segment, but it works just slightly different. Here, continue doesn't execute the particular script we're in. Here, continue goes on to the next line of code after the line that generated the error. So when I compile this, let's come up here and we'll run it. Gets this function created. And now when I run it, it tells me that I had an error, attempted to divide by 0, but then it went on and ran the rest of my function. So what if that wasn't a functionality we wanted? We wanted maybe to break out of the function and quit running. Well, to handle that, we have an alternate keyword of break. What a break will do is stop the function from running and go back up to the parent function. Now what it also does is it bubbles that error up to the parent. So let's come up here and we'll compile this and run it. There we go. And let's cause the error to occur. And now we get our error message, attempted to divide by 0, and oh no, an error has occurred. But PowerShell still throws out that really ugly error message to us. Another thing we can do is actually check for the specific error message. So here, I'm going to add an extra trap statement. And you'll also notice that I've moved the traps from the bottom of the function to the top. This is just to demonstrate that you can place these trap statements in here anywhere within the function. I could have even mixed them up with the individual lines of code, although it would be really pretty ugly and hard to read. What I advise you to do is to pick a place, either the top of the function or the bottom of the function, put your trap statements there, and then be consistent about it in all the functions you write. So here, in my trap, I'm going to check for a specific error with the first trap, system.divide by 0 exception. Now if that looks familiar, it's a .NET exception. Remember, PowerShell is a nice layer upon .NET, so anytime you need to look for a specific error, go reference your .NET error types, and that's what you're going to be looking for here after the trap keyword. So now if I find a system.divide by 0 exception, I'm going to display, hey Chowderhead, you can't divide by 0, and then I'm going to continue. Otherwise, I'm going to display whatever my generic message is, and with a break command. And yes, you can mix these up, so some of your traps use continue and some of them use break. So let's highlight all this and get it to run. And now it correctly displays you can't divide by 0. It doesn't display any of the custom error message, and we can continue on with our program. There's two main ways you're going to want to handle errors. In the first way, we're going to handle the error internally, which we've just done in that function. So that function you saw just now illustrated that. In the second way, we'd have to add trap logic within our parent that called that particular function. So we're going to do the same function again. The only difference is going to be that in our custom error, system.divide by 0 exception, we've changed the continue to a break. So let's come down here and get this to actually run. Now I've created a little script block. Within my script block, at the bottom, I have a trap, and then I just have the keyword continue so that my parent script will continue silently. So let's come up here and we'll execute this script block. So here we go. We got the results we wanted. We got the function to stop executing and return control back to the parent. Within the parent, we call the function and we silently suppress the errors by simply using a continue. The downside to this method is you wind up with a lot of these little script blocks within your overall PowerShell script application in order to trap and silently continue on these errors. There's no great way to handle this. Of course, the best way would have been within our function to simply check to see if the denominator was 0 and trap for that illegal input, give them the error message, and not ever hit the trap routines. But in those situations where you can't do that, know that you can use trap, and you can use it either to look for a generic error or that you can use it to look for specific .NET errors. We've done a lot with PowerShell so far, but one thing we really haven't touched on much is working with files. That's one of the more common things you're going to do in any PowerShell environment, so let's take a quick look at how to work with files. Now, you may have noticed in some of the directory listings I've done that I've had a series of files that had a single letter along with a .txt extension. These files actually contain the names of some of the courses that Pluralsight offers on their website, each file being from a different author. Let's look at one of them now. To retrieve the contents of a file, we use get-content, and then we simply pass it the file name. We can see here it lists all of the items that are in that file, and hey, these just so happen to be courses that I did. Now if I want to, I can actually assign the contents of a file to a variable. So there I've assigned the contents to the $A variable, and if I print it out, you can see I get the list of items. Now, it may look like everything's in one big string, but looks are deceptive. This is actually an array. Here, I can actually use my array syntax to get the first element, which is element 0. I can say get the third one, for example. And I can prove this because if I come here and I use getType, it shows me that it is an object, and the bracket syntax indicates that it is indeed a system.array base type. I can actually iterate over every single one of these and print them out. Now, a lot of the times, you may actually want to do what I just did, iterate over every single line that came in from the file and do something with it. There are times, though, when that may not be the results you wish. You may want to work with everything as one big object. So to do this, we can combine everything together using the static join function off of the string class. Now the join function requires two parameters. The second parameter is, of course, the file that we want to join together. The first, however, is the separator that's used to separate each line so that it knows how to join them. To get the separator, we're just going to use the system.environment new line to retrieve that new line and place it into the separator variable. Now we know because this is a Windows-based file, we could also have used the ~r ~n. You might also know that if you're pulling the file, maybe it came from a Unix system or something, it may only have either ~r or ~n as the separator. So here, let's do this. Let's join everything together, and we'll print it all out. Now it looks like it did before, but this time if I use getType on all, it tells me it's a string and not an array. The cool thing about getContent is it supports wildcards. So if you remember, I actually had 5 different files with course names in it. So by using the question mark, I actually can combine all of these files together at once. And there it is. It's actually loaded me a whole list of things. In addition to my courses, there's courses by various other Pluralsight authors. There we go. And of course, like before, I can use the join syntax to join them all together. Get content is used to get contents off the disk, so we'll use set content to put that data to the disk. Now, just to prove that data is not there, I'm going to write everything out to an allcourses.txt file, and this should return an error because getChildItems shouldn't be there. And sure enough it does. I get a nice big error because that file does not exist. So let's actually write it out now, and you'll see set content requires two things. It first requires a value parameter, in which case we take the text that we want to put out there and pass it in as a variable, and then we can use the -path to indicate what the file we want to put it to is. And there we go. Now we can use get content, and there's all of our data. Now be aware, set content is destructive. If I want to add this new PowerShell course you're viewing now to this list, and I set it out there using set content, and then I do a read from that, you can see only the PowerShell class is in there now. It has wiped out what we had before. If we want to append, we need to use the add content commandlet. So let me first reset this to put everything back out there. And now we can use the add content to add our new course. And there it is, it's put out there. Now we're going to clean up afterward, and we're just going to use remove item to get rid of that file because we don't need it anymore. Now that was working with text files, but we're not limited to that. We can also work with comma-separated value files. Let's first use it to save data out to a CSV file using the export-csv commandlet. The command we're going to use to pipe into that is getProcess. GetProcess simply lists all the processes that are currently running on the machine, as you see there. So now I'm going to run this, and it's going to populate the processes.csv file. Let's go open that up, and you can see that it is indeed a CSV file. There it is right there, and we're going to open it up in Excel. And there it is. There's all of the data that was in the process, and you can see Excel properly lined it up into the various columns that it needed. Okay. We can actually read things back in. To do so, we provide a header, and I actually just copied this header out of the CSV file. And then we use the import-csv. Import-csv requires two things, the name of the file, and then it requires a header so it knows how to break things up. When I actually execute this code and display the processes, you can see that it's listed all the processes, and in this case it was too big to support it in a wide format, so it actually took it and placed it into a more of a tabular type format. So let's come down here, and the next thing we're going to look at is XML files. XML files have become very, very popular, almost a de facto standard for doing data interchange these days. So next we're going to look at how to actually create an XML file. We're going to start by creating an XML template. And this XML template is just extremely simple. I have a courses, and it's going to hold a list of the Pluralsight courses that are out there in those 5 individual text files. We create our course template by using a here string, and I just have my overall courses. Then I have each individual course, and each individual course has a name and a level. And when I have that course template, I'm going to write it out to pluralsightcourses.xml. So let me execute this. Now I'm going to load that file I just created into a course XML file, and I'm declaring it this way so that I can actually force PowerShell to make this an XML type variable. So let's do that, and then on the second line we're going to use the .load method to actually load that data in there into the course XML variable. And that's taken care of. Now the only thing in my XML file is the template I just created. what I want to do is I want to grab a clone of that template and put it into a variable so that I can work with an individual item within my courses collection. And that's what this syntax here will do. The -0 will grab the first item in the collection, and then it clones it and puts it into this new course variable. Now the next thing I have is some syntax to import a comma-separated value that has a list of all my courses. Now if I come back here, you can see I've got an allcourses.csv file, and if I open that up in Excel, you can see I have two columns, my course name and the course level. Next thing I'm going to do is import these. Okay, now that they're imported into my course CSV variable, the next thing I want to do is iterate over all of those items. So I've got a simple for loop that's going to go from 0 to the number of items. It's going to first take a clone of that new course variable to create a new copy of it. Then it's going to assign the name from the course of the CSV. It's going to then assign the level. And then finally, it's going to take this new child called new course and it's going to append it to the existing course XML collection. Now at the end of that line, I've got a greater than sign, which redirects that output into the $null. If I don't do that, it's going to echo each one of these children as I append them to the screen, which is probably not a desirable outcome for most scripts. So we'll run that. And now we have the file loaded, but we also still have that template out there in the file. So what we want to do is get rid of that. So we're going to iterate over our collection of courses where the name of the course is blank. And for each one of those, we're going to remove it from our collection. Run that. Finally, we can save everything out to our file. Alright, let's make sure everything's out there. First thing we're going to do is open it up as a straight text file and display that. And here we go. Here is our XML file, and I'm simply displaying it as text. Most of the time, when you've got an XML file, working with it as text is kind of boring. What we actually want to do is work with it as XML. So to do that, we'll come down here, and we're going to create a new variable, and this time I can actually force it to be an XML variable by using the bracket XML in front of it. And I'm loading it at the same time from my file using getContent. Now that it's loaded, I can use a for each to iterate over each course in the courses collection and display its information to the screen. And there we go, 3 different ways to work with 3 different file types within PowerShell. I like to refer to this final section as putting it all together. Here, we're going to use many of the techniques we've learned throughout this video series in our final demonstration, and we'll learn a few new things as well. Most of the time, when you're doing your PowerShell script execution, you're going to be doing so through a PowerShell window, such as this one. Your interactions will be primary text-based, and it'll simply be executing a particular script that will go off and do things. There are times, however, when you need to do some interfacing with the users. For that, we'll need to know a few things about how to actually interact with the users and get information from them. So let's take a look at a series of scripts I have set up that will help us do that. Let's start by maximizing our code window. And what we want to do is we want to display a menu for our users and get some feedback from them. We're going to have a title at the top of our user interface. That title is going to be surrounded by a nice little box. We're going to display a menu, and we're going to ask them to enter a choice. We're then going to interact with them, displaying the choice they picked, asking for more feedback, and then ultimately saving that to a file. So what you see here is the code necessary to accomplish that. To help me out, I've created a few special little helper functions. Down here you can see one of them, set-app-colors. Another one is display app header. And then down towards the bottom I have one called write-text file. Now I'm sure you're probably thought by now, after watching our series on functions, that having to cut and paste our functions from one module to another is extremely inefficient. We should be able to create a library of functions that we can reuse in our various PowerShell scripts. And that is indeed the case. We can use this command up here called import-module. We can import as many modules as we need, and each module can have whatever amount of code it needs, and those modules could also have imports into them. Here I've kept it pretty simple. Let's take a look at the functions. I first have a function called set-app-colors. What we want to do is we want to change the colors of our user interface to make it look kind of spiffy. We'll have a black background and a green foreground. We're also going to change the title of our window to Putting It All Together. Now, when you're dealing with PowerShell, it's important to know what environment you're running in because the commands to change those colors are somewhat different. If you are running within the PowerShell Integrated Shell Environment, or ISE, there will be a special variable called $PSISE through which you can access several options of the environment. If you're running in a command window, however, that variable will be null. So down here you can see I compare it to null, and if it is null, hey, I must be running in a command window, and thus I use this set of commands to change my background, foreground colors, and the window title. Otherwise, I have a little more flexibility, and I can use these options to change my colors. I also get the ability with the ISE to use hexadecimal color codes, something I don't get with a command prompt. Next, I have a little helper function called getWindowWidth. GetWindowWidth is not used directly within my main code, however, it is used by the subsequent function displayAppHeader. GetWindowWidth is pretty straightforward. It checks to see where it's running. Now, if it's running in the ISE, it will not have a max window size. Thus, the max window size will be null, and I had to force a number in there, so I just picked 80. If I'm running in the command prompt, I actually can get a max window size, so I return that value to my window width. Next is the display app header itself, and it displays the title that is passed in the parameter. The first thing it does is it makes sure that there's a minimum length. It gets the window width using the getWindowWidth function you just saw. It then does a little math to determine how long the title is, and then it creates a padding to put on either side of the title in order to center it. It also uses this nifty little feature of PowerShell. Here, if I take a character, such as a space, and I use the multiplication symbol to multiply it by a number, it actually repeats that character however many times are indicated by the number. So here, I'm taking the width of the window, subtracting the length of the title, and then dividing that by 2 so I get equal number of spaces to either side of the title. I then repeat that little trick by multiplying a dash times the window width to get my top and bottom bars that are going to frame my title. Next, I move down to the right host. What the right host will do is it will print an asterisk, and then it will put the padding, then the title, then some more padding, and then another asterisk. I'm using the -no_new_line switch so that it does all of this on the same line. Additionally, I'm using a second switch called -foreground color so that I can specify a different foreground color, in this case white, for the title. Finally, I close out the function by printing my bottom border. The last function I created was called write-txt file. What write-txt file will do, it will take whatever is in the contents and write it out to the file within the $path parameter. It also has support for the -verbose and -debug switches. Write-text file actually has a little bit of extra functionality. If I scroll down, you can see that one of the first things it does is it checks to see if the file ends with a .txt extension. If it doesn't, it will append it for you. Now, in order to get that to work, I wanted to be able to use the .toLower and .endsWith features of the string data type. However, when parameters are passed in, by default they come in as an object. So I had to create a localized string variable called $filename, and I had to explicitly type it as a .NET string. This allowed me to call .toLower, .endsWith, and if .text was not present, to add it on. Next, I use a feature called test-path to see if a version of a .back file exists for this file. If so, it deletes it using the remove item. It then checks to see if the file name I'm targeting exists. If so, it renames that to the .back file. Finally, it saves out the contents. So you can see there's a lot of nice functionality here that I might want to reuse over and over again. Let's jump back to our putting it all together. And you can see what it's going to do is select a menu option, tell us that we think that choice is cool. It's going to ask what makes us think that. It's going to echo that back and ask us what file do we want to save it as. Let's actually execute this. Let me come back and put that. Now I want you to pay attention because down here all these colors are about to change. We're going to actually execute this, and it's going to ask us to select a menu option, and to do so within the ISE it pops up a dialog box. You can see down here it's printed out our title border, and it's asked us to pick something really cool, and it's listed out 5 items. Here I'm going to type out a number. We'll say number 1 because Pluralsight's really cool. But notice that there's no type checking within here. I can type in whatever I want to. So we'll just save it for number 1, and we'll click OK. Now it's going to come back and tell us, hey, you thought number 1 was really cool. What makes us think that? And we'll say something like great horses. And we'll say OK. And then it asks us to enter a file name we want to save it to, or we can click OK to just not save it. So I'm going to call this demo. I'm going to omit the .text extension, and we'll click OK. Now you can see the bar, which indicates that our script is now done executing. Let's come here and make sure our file actually exists. I'm going to use dir, which is an alias for getChildItem, and I'm going to pass in demo asterisk for the wildcard. And you can see that sure enough, our demo.txt actually exists. Also notice that after our script got done executing, we were left with the same color scheme. Now let's contrast that to what we get if we actually run this out of a script window. Here we go, and I've got the colors on this window set to white on blue. To actually execute a script out of this window, we have to prefix it by using dot, backslash, and then we can type in the name of the script. I can omit the .ps1 extension. When I hit enter, it clears the display, and this time instead of having a pop-up dialog, it just places the cursor on a line. And this time maybe I'll pick number 2. Oh, even better, let's pick number 5. In case you don't know what a Bugatti Veyron is, it's the world's fastest production car. It has a top speed of 264 miles an hour. So we're going to click enter, and it asks us why it was cool, and we're going to say it's because it goes really, really, really fast. Then I'm going to click enter, and it says, oh, that's a pretty good reason. Why do we want to save it? So we're going to type in demo again, hit enter, and now it's done. Now if I do another dir on demo, whoops, I got ahead of myself. I forgot to put the asterisk at the end. Dir demo asterisk. There's our demo.txt file. Now I want to point out something pretty important. Come back over here, and up here in our import line, this actually executes all of the code within this file. Now here I only have functions, so it executed the code that will actually create the functions for us. If, however, I had actual commands in here, such as remove item, create item, these kinds of things, then those commands would also be executed outside the context of a function. Just be aware that those kind of things can occur, but that can also be quite useful because you could actually create variables to hold things like maybe constants or something like that that the functions that you've got in here need. Also be aware that the functions only exist during the execution of the parent script. Up here I've got my, let's say the set app colors. Now if I try to do a get help here on set app colors, I'm actually going to get the help because the ISE still understands that these functions exist and are within its memory space. Let's contrast that by coming down here, and let's try to do a get help here. You can see I get an error because the set app colors no longer exists in the memory of the console. So just be aware that that kind of thing can happen, and there are some differences between executing code in the console versus executing code within the ISE. Now there are some times when you want to only execute code within the console. So to do that, you might want to create a little routine that prevents people from running things within the ISE. So to do that, I've just put together a very simple little function called prevent ISE execution. And here, all it really does is checks to see if that integrated shell environment variable is null or not. If it's not null, then it tells me it cannot run this script, and it issues a break, which will then bubble up and stop my script from running. Otherwise, it continues on and says, I must not be in the ISE. When I run this, you can see I get my you cannot run this script inside the ISE. If I come back over here to this window, remember we've got to use the // prevent-ISE execution. It actually said, hey, I must not be in the ISE, and it didn't give us the error message. So you should consider incorporating something like that into your scripts if you need that functionality. One of the things that made this work really is the piece of code here called read-host. Read-host is what allowed us to display a prompt to the screen and return that choice to a variable. In this case, I first returned to $choice and down here to $reason. You also saw that read-host was implemented differently between the ISE and the command window. In the ISE, it popped up that little dialog box, but in the command window, it just put the cursor at the end of the prompt and waited for us to type something in. Be aware that different environments can handle these kind of things differently. In this series, we've used either the PowerShell command window or the PowerShell ISE for all of our work. That's because they're available with every installation of PowerShell 2.0. Be aware, though, that other PowerShell editors do exist. Two free ones you may want to look at are PowerSE and PowerGUI. There are also several very nice PowerShell editors for sale. Because of the extreme simplicity of the integrated shell environment, you're soon likely to migrate to another, more fuller-featured development environment. Even so, it's worth knowing about the Microsoft-supplied ISE, since you know it will be available on each box where PowerShell 2 exists. Phew! We finally made it to the end of our series on PowerShell. In this module, we dove deep into the real power of PowerShell programming by learning about functions. Beyond the basics of functions, we learned how to add help to them and manage errors. We also saw how to work with 3 different file types, as well as construct a user interface. Now that you have the skills to write your own PowerShell programs, I'd encourage you to begin looking at the many providers available for PowerShell. We touched on providers all the way back in Module 1, and it's through providers that your own PowerShell applications will be able to interact with the rest of the world. Thanks for watching.